Hello everyone, welcome to this new mathematics session for grade 9. So today we are going to continue with our topic of quadratics, and in this session we are going to learn firstly how to solve quadratic equations, and secondly how to solve problems involving formulation of quadratics. Right? So we start with solving quadratic equations. The first example, here we are told to solve the following equation, and we are given 2 over x equals x over 8, right? If we observe this equation very carefully, on the left hand side we have only one fraction. And on the right hand side, again, we have only one fraction. And in the middle of these two fractions, we have equal to. Whenever you have a situation like this, where you have only two fractions on either side, one fraction on the left, one fraction on the right, and in the middle you have equal to, then it is better to use what we call cross multiplication. Right? Always keep this in mind. When do we use cross multiplication? Whenever you have only one fraction on the left and only one fraction on the right, and in the middle you have equal. Okay, so we are going to use the method of cross multiplication here. Okay, so we start by writing cross multiply. Right? Whenever you are using cross multiplication, always start with the unknown, and here the unknown is x. So I am going to start with this x. You can also start with this one, right? So I start in this direction. I multiply the 2x, x times x equals, in the other direction, 8 times 2. X times x is simply x squared equals 8 times 2 is 16. Okay, now what have we got here? We have obtained what we call a quadratic equation, and this type of equation you already know how to solve from the previous sessions, right? How do we solve a quadratic equation? By simply making the right hand side become 0. Then we use factorization. Okay, let's do it. So I will send the positive 16 on the left to obtain x squared minus 16 equals 0. Now if you take a look at the quadratic expression on the left, we observe that 16 is a square number, and in front of the x squared, again you have 1, which is also a squared number, right? So this expression on the left, let me continue here. This expression on the left can be written simply as x to the power of 2 minus 4 to the power of 2 equal to 0, right? Why have I written the expression like this? Because if you recall, we know that when we factorize a squared minus b squared, we obtain a plus b times a minus b, right? So in our case, instead of the a we have x, instead of the b we have 4. So easily we can factorize this expression to give x plus 4 times x minus 4 equal to 0. Then what is the next step is simply to equate the first factor and the second factor to 0. So we say either the first factor, which is x plus 4, is 0, or the second factor, which is x minus 4, is 0. And simply we write down the answers now. X plus 4 equal to 0, meaning x is negative 4. Here we have x minus 4 equal to 0, meaning x is positive 4. So these are our two solutions to answers, right? This is how we solve this type of equation. Now there is a second method which I will explain to you. It is important also to know the second method. I take the given equation again. Let me do it here. The method number 2, right? So we are given this equation 2 over x equals x over 8. Again we use cross multiply. X times x is x squared equals 8 times 2 is 16. The first step is the same as the previous method, right? Now instead of using factorization, we are going to find x directly. If you recall from your knowledge of grade 8, the chapter of square root and Pythagoras theorem, right? You had questions like this: x squared equal to a square number, right? Then how did you find x? At the end, we need to find the value of x, or the values of x in this case, because it is a quadratic. We are going to obtain two values of x. We simply have to remove the power 2. And how do we remove the power 2? Always remember this: to remove power 2, we have to take square root. So in our case, x is equal to square root of 16 with a plus and a minus in front. Why we put plus and minus? Because we are dealing with a quadratic equation, and as I have told you before, a quadratic equation, we must obtain two answers. That is why we put plus and minus in front of the square root. So we continue. This will give x equal to plus and minus. What is the square root of 16? It is simply 4, because 4 times 4 gives 16. So root of 16 is 4. So again, we obtain two answers: x equals positive 4 or x equals negative 4, right? Okay, so this is the second method that you can use. You decide which method is more appropriate for you. Now we continue with another example. Here we have 25 over x, which is a fraction on the left, only one fraction on the left, equal to x on the right. Now, the right hand side of the equation, it is x, and x we can write it as x over 1. It's the same thing because x over 1 is simply x. Now we are in a situation in which we have only one fraction on the left and only one fraction on the right. So now we can use cross multiplication again, right? So let us perform the cross multiplication. We are going to cross multiply. We start with this x, so x times x equals 1 times 25, right? X times x is x squared equals 1 times 25 is 25. Again we have got a quadratic equation. Now you decide which method you are going to use. As from here, either you use factorization or you use the second method, right? I will do both methods. The first method is I will use factorization. I send the 25 on the left, so it becomes x squared minus 25 equal to 0, and we note that 25 is a square number, and in front of the x squared we have 1, which is also a square number, so we can write it as x power 2 minus, and the 25 is simply 5 power 2 equals 0. So it is in the form of a squared. It is in this form, a squared minus b squared, which we can easily factorize to give x plus 5 times x minus 5, and we simply equate each factor to 0 now. Either the first factor x plus 5 is 0, this will give x as negative 5, or the second factor x minus 5 equals 0, this will give simply x equal to positive 5. So these are our two solutions, right? Two answers. Now the second method, method 2, we have 25 over x equal to x is simply x over 1. Again we use cross multiplication. X times x is x squared equal to 1 times 25 is 25. Now this method, directly we find x by removing the power 2. To remove power 2, we have to take root of 25. And when we take root, we have to include plus and minus in front. So this gives x equal to plus and minus. What is root of 25? Root of 25 is simply 5. Again, we have our two answers. X equal to positive 5, which is simply 5, or the second answer, x equals negative 5, right? Both methods will give you the same solutions. A third example, here we are given 3x minus 4 over x equal to x over 2. Again, we have only one fraction on the left, only one fraction on the right, so we can use cross multiplication, right? So we start. I'm going to start with this x. X times x equals the other way now. 2 times, you have to use bracket here, 2 times 3x minus 4. And we have to simplify now. X times x is x squared equals, on the right hand side we have to expand. 2 times 3x is 6x. 2 times negative 4 is negative 8. Now simply we have to make the right hand side become 0. Right? Here we can't use the second method because we have x on the right hand side. Okay, so we send the 6x and the negative 8 on the left. So this gives x squared. The 6x, when you send to the left, it becomes negative 6x. And the negative 8, when you send to the left, it becomes positive 8 equal to 0. Right? Now the quadratic expression on the left has 3 terms. I hope you remember how to solve, how to factorize this type of quadratic. A quadratic having 3 terms, when we factorize, we obtain 2 brackets, right? And the method here to factorize this quadratic expression on the left is to use the magic X method, right? So we are going to use the magic X method here. So we draw our X. What is the leading coefficient? X squared. The leading coefficient is 1. So we take 1 times the last term, the constant is positive 8. 1 times positive 8 is positive 8. And secondly, we take the coefficient of x, which is negative 6. Right? All we have to do now is to think of 2 numbers. We have to think of 2 numbers which, when we multiply, give positive 8, and the same two numbers add to negative 6. Let us think of these numbers. Let us take multiplication first. What 2 numbers, when we multiply, give positive 8? We have 1 times 8, or negative 1 times negative 8, or 2 times 4, or negative 2 times negative 4, or 4 times 2. It's already here. 8 times 1, and so on. So from these possibilities now, let us choose the 2 numbers which add to give negative 6. Is it the first one? 1 when you add with 8. Do we get negative 6? No. The second one, negative 1 when you add with negative 8. We obtain negative 9. We don't obtain negative 6. The third one, 2 when you add with 4. It gives positive 6. But here we want negative 6. No. What about the last one? Negative 2 when you add with negative 4. This gives negative 6, of course. So this is our combination, negative 2 and negative 4. And what we have to do now, we have to divide both numbers by the leading coefficient, which is 1, right? Now all we have to do now is to fill in the pairs of brackets. We start with the denominator here. We have 1. It becomes the quotient of x in the first bracket. The second denominator, 1 again. It becomes the second quotient of x in the second bracket. Then we take the numerators, -2, insert it in the first bracket, and -4, we insert it in the second pair of brackets. Right? So we are almost done. We continue here. 1x minus 2 is simply x minus 2 times 1x minus 4 is simply x minus 4. This equals 0. All we have to do now is to equate each factor to 0, meaning either x minus 2 is 0, this will give x equal to 0 plus 2, our first answer, or the second factor now we equate to 0, x minus 4 is 0, x will be 0 plus 4 is 4, our second answer, right? You see, that is why I have told you before to know all your types of factorization very well. Now we move on to another important part of this chapter, which is formulation of quadratic equations. Right? For this part of this chapter, we won't be given the quadratic equation. We have to form, we have to develop the quadratic equation and later solve it. Right? And this is what we call formulation of quadratic equations. We have to formulate, we have to develop. Right? So let us see this through this example. We are told the diagram shows rectangle ABCD. So we can clearly see our rectangle here. The rectangle ABCD with AB equal to x centimeters. So the length of AB, this length here is x, okay. And BC equal to x minus 7 centimeters. So the width of the rectangle is x minus 7, okay. We can clearly see it. And we are given the area of the rectangle is 120 centimeters square. Okay, the area is 120. That's fine. We need to find x. And what is x in our case? X is the length of the rectangle. So indirectly the question is saying to find the length of the rectangle. So how do we start this type of question? Right? You have to observe the question very carefully. The question tells you about the area of the rectangle. So this is where we are going to start. We are going to start with area of the rectangle. Right? And you already know how to find the area of a rectangle. Area of rectangle is simply the length times the width. And what is the length of the rectangle? The length is x. And what is the width? X minus 7. X times x minus 7. And this can be written as, let me continue it there. So we have area of rectangle is x times x minus 7, and this can be written as simply x times x minus 7 like this. Then we can expand the brackets. X times x is x squared. X times negative 7 is negative 7x. So this is the area of the rectangle. Yes or no? From the given diagram here, from the given figure. Now, if we read the question, this sentence here, given that the area of the rectangle is 120 centimeters squared, the area is 120, and we have obtained the area as x squared minus 7x. So this area of x squared minus 7x must be equal to 120, right? So we say that since the area of the rectangle is 120 centimeters squared, comma, therefore our area that we have got, x squared minus 7x, it's for the same rectangle, and this area must be equal to 120, right? So we have got a quadratic equation now. You see, this is what we call formulation of quadratic equations. Formulate, to develop the equation. We were not given the equation. We had to formulate, we had to develop the equation. So here we have reached a point where we have obtained the quadratic equation. Now to find the value of x, we simply have to solve this equation, right? And you already know how to solve this equation by sending the 120 on the left and using factorization, right? So let us send the 120 on the left. We obtain x squared minus 7x minus 120, and this equals 0. Now we have to factorize the expression on the left hand side. So let us continue with this question on another slide. So we have reached here x squared minus 7x minus 120 equals 0, right? So all we need to do now is to solve this equation, and like I have said, we need to factorize the left hand side of the equation, right? So let's do it on another slide. So here we are. We have x squared minus 7x minus 120 equals 0. The quadratic on the left has 3 terms, and when you factorize this type of quadratic, we obtain 2 pairs of brackets, right? And we are going to use which method here? The magic X method, right? Again, the magic X method comes into play. The leading coefficient is 1, so we take 1 times negative 120. We have a negative 120. Then we take the middle coefficient, which is negative 7. Now we have to think of two numbers which, when we multiply, give negative 120, and the same two numbers, when we add, give negative 7. So what are these numbers? Let us consider multiplication first. What are the two numbers which when we multiply give negative 120? So I write it here. I have 1 times negative 120 or negative 1 times 120 or 2 times negative 60, negative 2 times 60, 3 times negative 40, negative 3 times 40. Then I have 4 times negative 30 or negative 4 times 30 or 5 times negative 24 or negative 5 times 24 or 6 times negative 20 or negative 6 times 20, 8 times negative 15, negative 8 times 15. I have also 10 times 12, 10 times negative 12. Let me write it here. Or negative 10 times 12. So these are the combinations. It's pretty long list of combinations. Now from this we have to select two numbers which add to give negative 7. Is it the first one? No. The second one? Still no. Third one? No. We continue like this? Still no. 4 with negative 30? No. We continue to delete 6 with negative 20. It's negative 14. No. Negative 6 with 20. Positive 14. What about this? 8 with negative 15. When we add 8 plus negative 15 becomes 8 minus 15, and this gives negative 7 as required here. So this is our combination. So we select this 8 negative 15. So we write it here. Then we divide both numbers by the leading coefficient, which is 1. And we simply have to fill in the brackets now. Start with the denominators. First denominator is 1, it becomes the quotient of x in the first bracket. Second denominator 1, it becomes the other coefficient of x in the second pair of brackets. Then we insert the first numerator, it is positive 8. The second numerator, negative 15. So we are almost here. This is simply x plus 8 times x minus 15 equals 0. Now we have simply to equate each factor to 0. Either x plus 8 is 0, the first factor, which gives x as 0 minus 8, negative 8, or the second factor, x minus 15 equals 0. This will give x as 0 plus 15, which is 15. So these are the solutions to this quadratic equation. But now, since here we are dealing with rectangle, we are dealing with area of rectangle, and area is related to length. To obtain the area, we take the length, multiply the width. So we are dealing with length. And in the drawing, in the figure, x in fact represents the length of the rectangle, Whenever you measure length, can length be negative? Suppose you measure the length of a table, whatever. Do you obtain it as negative? We never obtain the measurement of length as negative. So in this question, we have to take x as positive 15 to be the final answer, because x cannot be negative. So in this case, x equals negative 8, the first answer, we are going to reject the first answer. So this answer here, I write it, reject, and our answer to this question is x equal to 15, because length cannot be negative. It has to be positive, so we take the positive value to be the answer. Right, again, always keep in mind that length cannot be negative. So you have to take the positive value for the answer. Let us see another example now, still concerning formulation of quadratic equations. So we go through this question. We are told ABC is a right-angled triangle, as we can see. The length of AB is x, the length of BC is x plus 1, and that of AC is x plus 2. Okay, we all can see this. The first question, part A, tells use Pythagoras theorem to show that x squared minus 2x minus 3 equal to 0. So we need to apply Pythagoras theorem in this triangle here until we reach this quadratic equation that has been given. Right? Indirectly the question says we need to develop this quadratic. We need to formulate this quadratic equation from what we have from the triangle. And how can we formulate the quadratic equation from the triangle? It's by using Pythagoras theorem. Okay? And part B of the question says we need to solve the equation and find its perimeter of the rectangle. Okay? So let's start with part A. So we need to apply the Pythagoras theorem, right? And how do we apply the Pythagoras theorem? We have to label the sides of the triangle first. Opposite to the 90-degree angle, we have the longest side, which is AC, and we call it the hypotenuse, right? And the other side, one of them, I will call it side 1, and side BC, I will call it side 2. So this is the starting point. Then we are going to write down the Pythagoras theorem. It simply says the hypotenuse to the square equals side 1 to the square plus side 2 to the square, right? And what is the hypotenuse in our case? The hypotenuse is x plus 2. So this is the hypotenuse. Then we have to put the square, of course, equals, and what is side 1? Side 1 is x here. Again, we have to write down the square, plus, and what is side 2? Side 2 is x plus 1. Then we have to again put the square. Now all we have to do now is to simplify this equation, right? We need to simplify this equation until we reach with this one here. This is the question of part A, right? So how can we simplify it, right? I continue here above. So the left hand side is x plus 2 to the square. It is simply x plus 2 times x plus 2, right, equals, the next term here is x to the power of 2. It is simply x squared plus, and the last term here is x plus 1 to the squared, meaning x plus 1 times x plus 1, right? And now we have to expand the pairs of brackets. X times x is x squared, x times plus 2 is plus 2x, plus 2 times x is plus 2x again, and plus 2 times plus 2 is plus 4, and this equals, here we have x squared, we write it, we have a plus, no problem, you write down your plus, again we expand x squared, x times plus 1 plus 1x plus 1 times x plus 1x plus 1 times plus 1 is plus 1, right? Now we simplify. Here we have x squared plus 2x plus 2x is simply plus 4x, then plus 4. Here we have 1x squared, again we have 1x squared, 1x squared add with 1x squared gives 2x squared, and here plus 1x plus 1x plus 2x, and the last term plus 1, right? Now we need to reach this equation here where the right hand side is 0, and we are at this step here. All we need to do is to send all terms on the left so that the right hand side becomes 0. So let's do it. On the left hand side here I have x squared plus 4x plus 4. Then I send the positive to x squared there, it becomes negative 2x squared. The plus 2x there, it becomes minus 2x. The positive 1, it becomes negative 1, then equals 0. Now we have to add and subtract the like terms. So I take 1x squared, I group with negative 2x squared. So these are like terms that can be added or subtracted. Then I take the term in x, which is plus 4x with negative 2x. Again, these are like terms. We can add and subtract. And lastly, we take the plus 4 minus 1 equals 0. Now we simplify 1x squared minus 2x squared. It gives negative 1x squared plus 4x minus 2x. It gives plus 2x, and plus 4 minus 1, it gives plus 3, and this equals 0. Now, is this equation here, is this equation the same as that of the given question? We need to reach here. This is our main goal here. We need to reach this equation. Is it the same? Here we have x squared, meaning positive 1x squared. And in our case, we have negative 1x squared. Is it the same? No, it is not the same. In our case, it's negative 1x squared. And we need to reach positive 1x squared. So we need to make an adjustment of the sign here. Right? So how can we reach the required equation? Simply by multiplying each term by negative 1. So negative 1 times negative 1, it becomes positive 1, of course x squared. Negative 1 times positive 2x, it becomes negative 2x. And negative 1 again times positive 3, it becomes negative 3, and this is equal to 0. And as you know, positive 1x squared is simply x squared. Then minus 2x minus 3 equals 0. Right? So now, is it the same equation that has been told in the question? X squared minus 2x minus 3. Yes. So here we are. We have developed this equation by applying Pythagoras theorem. Okay? You have to be very careful with the simplification involved when expanding brackets, when bringing like terms together, and when adding and subtracting. Right? Okay, so this is the first part of the question. And the second part was to solve the equation x squared minus 2x minus 3 equal to 0. So let's solve the equation x squared minus 2x minus 3 equals 0. So the left part of the quadratic equation, we have our quadratic equation here. The left part has how many terms? 3 terms. So when we factorize, we're going to obtain 2 pairs of brackets, and we are going to use again the magic x method. So I write it down here. Our magic x, the leading coefficient is 1, so 1 times negative 3 is negative 3. Then we take the middle coefficient, negative 2. We have to think of 2 numbers which when we multiply give negative 3, and the same 2 numbers when we add give negative 2. What are these 2 numbers? Let us consider multiplication first. So when we multiply the 2 numbers, we must obtain negative 3, meaning 1 times negative 3 or negative 1 times 3. Do we have other possibilities? No. So is it the first one? When we add now, when we add the 2 numbers, we must get negative 2. Is it the first possibility? 1 when you add with negative 3. Do we obtain negative 2? Let us see. 1 plus negative 3. It becomes 1 minus 3, which is negative 2. So yes, it is the first combination. So we write down 1, negative 3. Okay, then we have to divide by the leading coefficient, which is 1. Then we fill in the pairs of brackets. We start with the denominator. 1, it becomes the coefficient of x in the first pair of bracket. The second denominator 1 again, the coefficient of x in the second pair of brackets. Then we insert the first numerator, positive 1. the second numerator negative 3, right? This is simply x plus 1 into x minus 3 equals 0. I continue here. Now I have to equate each factor to 0. We say either the first factor, which is x plus 1, this equals 0. This gives x simply as 0 minus 1, x is negative 1 here, or the second factor, which is x minus 3 equals 0. So this gives x as 0 plus 3. This gives x as 3. Now again, this is a question of application, a question of formulation. You have to select your answer. Will it be the first answer, x equal to negative 1? Will it be the first answer? If we take a look at the given diagram, which is a triangle here, we are saying x is negative 1. X represents a length. Can length be negative? No. So the first answer, x equal to negative 1, right? For this question, we are going to reject it, right? Why do we reject it? The first answer here, we are going to reject this first answer, and we are going to take x to be 3. Why? Because 3 is positive, length is definitely positive when we measure, right? So we are going to use x as positive 3 to find the perimeter of the triangle, right? So let us plug in x as 3. So we are taking x to be 3 so that the dimensions of the triangle become, here we have x and we are saying x is 3, okay. Here we have x plus 1, meaning 3 plus 1, which is 4. And AC, the length of AC is x plus 2, meaning 3 plus 2, which is 5. So now we can easily find the perimeter of the triangle. We start with 3 plus 4 plus 5, and this gives 12, of course, centimeters, right? I hope you have understood formulation of quadratics. It is not difficult. It's a bit lengthy, it's a bit long, I know, but you must be very careful with your factorization and simplification, right? And you have to know how to select your answer for x in a particular question, right? So this is the end of this lesson. See you for the next session.